Okay. All right. Inequalities do weird stuff sometimes, right? Like, thinking back, you can at least think about if you divide by a negative, the inequality flips around, that kind of thing, right? Well, absolute value, because it's about distance and distance from zero, and we kind of interpret that as being a ignoring direction thing, right? Well, because of that, it kind of brings in this idea of opposites and negatives and that kind of stuff. So we got to be really careful with the inequality kind of all the time, but in particular when there's an absolute value involved like this. So what we're going to do, similar to what we did yesterday, is first, I'm just going to ignore this. Solve the equation. Equations don't do weird stuff, really, right? They don't do the same kinds of weird things that inequalities do sometimes. So solve the equation because it's a little more concrete. How should we go about doing that? What can we do to solve that equation? This is where that distance thing comes in, right? Read that equation for me. Okay, McKinley, just read this off for me. Okay, the absolute value of, who cares, something. What does absolute value mean again? Distance. Okay, the distance of something is 3. The distance from 0 is 3. If the distance from 0 is 3, where are you? 3 or -3. Those are the only options. Okay, so we don't care about what the thing in absolute value is just yet. We will in a second. But if the distance from 0 is 3, you can either be right there or right there. That gets rid of or decomposes or eliminates the absolute value part of it. Now I can go look at the details and figure out, where to go from here. Okay, so solve those two things. What do we do? Add 2. -1, 5. Okay, we have the 2 solutions to the equation. We know the 2, and there are only 2 places where this thing, the absolute value of x minus 2, is exactly the same as 3. We want to know where it's greater than 3. Well, everywhere except for -1 and 5, it's either going to be bigger than 3 or it's going to be smaller than 3, right? Because those are the only options, right? When you compare 2 things, we know where they're equal. We're trying to figure out where they're unequal in, the right way, where it's bigger than 3. So y'all go ahead and get back into groups and stuff. Figure out, look through what we did yesterday, set up, some kind of way to organize what you're thinking about things and test around those 2 points. Okay, so again, what we want to figure out is where that absolute value thing is bigger than 3. We know that it's equal to 3 when x is -1 and 5. So here's the whole x-axis, right? At -1 and at 5, these things are the same. What we want to know is what happens everywhere else. So what happens is you take the whole x-axis, you break them into 3 chunks. There's this stuff that's bigger than 5 or to the right of 5, then there's 5. Well, I know what happens there already, right? That's why I marked it, because I know that they're equal there, which means that I know that 5 is not going to be, sort of part of my solution here, because I want to know where it's greater than, not where it's equal to, right? Okay, so that's why I've kind of blocked it off. Then there's the stuff between 5 and -1. Then same thing happens at -1. And then there's the stuff left of -1, right? So what do we do here to figure this out? Take something from each of those intervals, whatever you want. Pick a representative, right? So something to the left of -1. And something between -1 and 5. And something bigger than 5. Doesn't matter what it is, just something that's on that side of it, right? So same way you would see it on a number line. Okay, then what do we do with them? Plug it in, see what happens. All right, let me make some room here. All right, so if I plug in x equals -2, we get 4, right? Is 4 bigger than 3? Yes. Okay, it works there then. I want to include that piece, that interval, in my solution set then, right? Because the inequality was true there. The thing that we're trying to solve works, right? I plugged in -2. -2 was just my representative, my sample point. Anything out there would do the same thing, right? That's the whole point. So I plugged that in, I got 4. 4 is bigger than 3, so cool, I'm going to keep that piece. What if x is 0? It's 2 bigger than 3? Nope. So what does that mean? Can't include that piece, right? The inequality is false there. I don't get a thing that actually works. That means graphically that the graph is sitting underneath the whatever we're comparing it to, 3, sitting lower than 3, right? The y values are smaller than 3. Okay. So I'm not going to include that piece then because it doesn't work, right? The inequality is not true there. And then 8. We get 6. 6 is bigger than 3. So I'm going to include that piece as well. What about the endpoints? Parentheses, why? We want strictly greater than rather than greater than or equal to. What happens at the endpoints? If x is -1 or if x is 5, what do we get on the left-hand side of this? 3, right? Well, 3 is not greater than 3. So I don't want to include those. I want to go sort of right up to them, but not include them. So the solution set for this thing is what? It's the stuff I got shaded in pink there at the bottom of the number line. -infinity to -1, then a union, and then 5 to positive infinity. So it's everything outside of those two values that we found, right? V-shaped graph opening up, we're comparing it to 3. So that's kind of the picture. You're looking for where it sits higher than that line 3. So it's the stuff outside of those points. Okay, without doing anything at all, just writing it down, we can answer the second one then, right? Absolute value of x minus 2 less than or equal to 3. What has changed? Just the way we're comparing them, right? It's the same expression. It's the same number we're comparing to. So what's the solution going to be there? Everything, all the stuff we did here about testing whether this inequality was true or false, all those just flip when we flip the inequality, right? So what is it? Well, let's be careful. We want less than or equal to 3, right? So if I flip these inequalities, now I'd be asking, is 4 less than 3? No. Is 2 less than 3? Yes. Is 6 less than 3? No. So we want the stuff in the middle, right? In between rather than outside. So -1 to 5. And now we should be using, because it's less than or equal to, brackets. Okay. And again, I can do that because it's the exact same expression. It's the absolute value of x minus 2. I'm still comparing it to 3. I'm just comparing it the opposite way, right? I'm looking for where it's less than rather than greater than. Okay, so that's going to be kind of the basic, idea or pattern. Solving inequalities. And this is what we're going to do all semester. Like, this is how I'm going to solve inequalities all along. If you have a different way that you want to organize stuff, I'm not saying that yours has to look exactly like mine, but somehow you have to show me that you are checking what the inequality does, whether that's, by looking at the graph and testing for where it sits above or below. If you're doing that, to draw the graph out and write some stuff down, or checking points like this, or doing something though. You can't just come up with -1 and 5 and then write down an answer and hope to get credit for it, right? Because, once you do a few, this will make more sense, but it's either a thing that looks like that or it's a thing that looks kind of like that. So you got to do something. It doesn't have to look just like mine, but it does have to, sort of prove your point. You can come talk to me if you have questions about that. But solving inequalities, we need to solve the equation first. So replace the inequality with an equal sign. Again, the reason that we do that is that equations are a little more concrete. They don't do weird stuff like, the thing doesn't flip back and forth. There is a way to do this sort of directly with the inequality, but there's a weird thing you just have to remember. I don't like weird things that you just have to remember. So solve the equation first, then test the inequality somehow. I'm testing it by picking test points and plugging them in. You could test the inequality by looking at a graph. That would be basically the same idea, just kind of a different way of doing it. And then write down your solution set. You do also want to, this is a place where, once you get into the homework a little bit and work a few problems, you'll start to notice patterns. You always want to be sort of cautiously optimistic about that kind of thing. Like, patterns are good. A lot of math is about patterns. You don't want to trust patterns too much though, okay? Because there are times that, later on, the thing that works here may not work later, if that makes sense. So that's why I'm testing all 3 of these intervals. I'm not just doing the first 2 and then saying, oh, I know what the pattern says should happen next. If that makes sense, it might make more sense once you've done a few more problems on your own. Okay, so you should be in good shape then to work through some stuff there. Take a look at number 4 real quick. What would be a good first thing to do here? Say again. Okay, yes. Replace the inequality with an equal sign. What would be a good second thing to do? Move that 1 over. Yeah, why move that 1 over? get the absolute value by itself. Why do we care about getting the absolute value by itself? What have we been doing to get to sort of break up or get rid of the absolute value? Using the, we're going to subtract it over. Using this distance idea, right? Okay, well, that part only makes sense if we're sort of looking at it like in isolation by itself, right? Because if there's a bunch of stuff going on around the absolute value, I can't say in quite the same way, exactly what it means. So what I would do, immediately after that is move that 1 over to get the absolute value sort of all by itself. Once it's all by itself, and we'll see this in a lot of places all semester long, but once it's all by itself, now I can really think about, what that tells me, what that means, and go from there. And we should be in, pretty good shape after that. But yeah, I don't want to really start thinking about like the distance thing and what the absolute value means until we've got it by itself, because now I can say the absolute value of something is 2. So the distance of something I don't care about yet is 2. That tells me where it is. Then I can sort of start breaking things down. Right? Okay. All right. Flip over to the back. Tell me about what you see here. So that is the graph of the absolute value of 3x plus 6. We want to find, basically we're answering these questions, right? In place of y, I'm putting this function. Not really sure why I wrote it out the way I did. Now that I'm looking at it. But we're answering each of those things. Where is it equal to -2? Where is it less than -2? Where is it greater than -2? So what do you think? Same thing as before? Is it any different? Do we just jump into it and start doing what we've been doing? What happens if we do just kind of try to jump into it? Right, absolute value 3x plus 6 equals -2. Well, what have we been doing to sort of break down the absolute value? Thinking about distance from 0, setting it equal to, sort of the distance to one side and the other. But what does this say? The absolute value is negative. Does that make any sense? No, why not? It's absolute value, right? Absolute value is always non-negative, right? Absolute value is how we describe the size of a number as its distance from 0 without worrying about which direction it is. It doesn't make any sense for it to be negative because all a negative is telling me about is direction, right? Just like I don't say that the wall is, -2 feet away from me, I say it's 2 feet behind me. So this doesn't really make any sense. Nothing is going to stop you from writing, don't write this down, but nothing is going to stop you from saying, okay, well, this is -2 or it's 2, because that's kind of what we've been doing. And you can work through those and you can get numbers, right? It's just that they don't make any sense, right? They don't mean anything. Think about it from the graph. So like we should not do that. Think about it on the graph. What does it mean to compare this to -2? Is -2 an x or a y there? A y. Where's y equals -2? Right there. Where's that graph cross that? Because it's sitting above it, right? And moving away, right? So it never crosses that. Okay, well, what does that mean about solving this equation? It has no solutions. Right? Because those things are never equal. They never intersect. They never cross. Solving that equation means find the x values where these things are the same, where they cross, or they're not. Okay, what does that mean about where this is less than -2? Same thing, it's not, right? You might, if you haven't seen it before, you might also see for no solutions, you might see a couple places where like the stuff online or a book or whatever uses that symbol. That means the empty set. It just means the same thing. It's the cool math symbol for saying no solutions. There are no values that satisfy that. What about the last one? Where is the absolute value of this thing or that function? Where is it greater than -2? Everywhere, right? It's always bigger than -2. Okay, so how do I write that? Okay. Infinitely many solutions. Yeah, all, if this was no solutions, this is like all solutions, all x values are solutions. If I'm going to write it as an interval, it'll look like that, or all real numbers, or something along those lines, right? No matter what x value you give this thing, you plug in here, you're going to get something on the left that's bigger than -2. Because it's an absolute value, the absolute value is always bigger than a negative number, right? So the point of this is that as you're working through problems and stuff, when you sort of, like we did on that last one on 4 that we talked about, you can't always tell right off the bat because there could be other stuff going on around sort of outside the absolute value. Before you start actually like digging into the problem and breaking down the absolute value and stuff, stop for a second and think like, does this actually make sense, right? Because if I'm comparing to a negative number, then no, it doesn't, right? So we're either going to get no solutions or we're going to get, sort of all real numbers as solutions, depending on which way that comparison goes. Okay, so I'll leave it there. Y'all do some homework, and if we have more questions about that, we can talk about them later. I want to real quick talk about piecewise functions too, though. Here's a graph of a thing. Take just a second, find each of those function values. So just looking up, give it an x, find the y. The graph is weird. It's different than stuff we've looked at. That's okay. You can still do the function evaluations the same way. All right, so if x is -4, what's f? 5. Find -4, find the function, take the y value, right? Okay. What if x is -3? -1. What happens at negative or at, what happens at that x value that's weird? Sort of looks like the thing shows up in 2 places, but this one's not included, but this one is, right? So at -3, I want to take this one that's filled in, the one that's included. So that would be -1. All right, what about 0? 0 would be 2, and 4. See some shrugs, people shaking their heads. What happens at 4? The only thing I see, if I just look straight up and down at 4, oh, sorry, look, go ahead. Yeah, basically it's undefined, right? The function is literally not defined there because The only thing I see at 4 above or below me is an open, missing, deleted point, right? So I can get close to it, but I can't actually reach it. Unlike what happened over here at -3, there's not a different point that picks it up somewhere. So basically at 4, the function just doesn't exist, right? So I would say that that's undefined. Like 4 is not in the domain of this function, in other words, right? If I was going to write the domain down, I would have to use like parentheses to show what happens at 4, right? We can get close to it, but not included. All right, so this is what we call a piecewise defined function. I can't write all that down. Like this graph is a mess, right? So I can't write a single equation that describes what that thing does. So instead, we define it in pieces. The way you define it in pieces looks something like this. This is the way you write down the equation, the function that's shown in that graph. The way you read this is f of x equals, okay, so we're defining a function. Big curly braces basically always just mean this stuff all goes together. So this stuff all goes together. And what it looks like is y equals 5 when x is between -5 and -3. And then it looks like x plus 2 when x is between -3 and 1. And then it looks like -2x plus 5 when x is between 1 and 4. Right? So the right-hand part, the inequality stuff, that's just telling you when to use that rule. And this is sort of showing you like what it looks like. Right? So this is the function, if you want. And this is like when to use each piece. This might be an example that nobody really clicks with in this group, but does anybody like work through like filing your own taxes? No? Okay. Okay, yeah. So it's like tax brackets, right? Like based on your income, you follow a different set of rules for filing, right? So it's a little bit like that. This tells you when to do each thing. This tells you, like what to actually do. Something like a data plan for a phone would be similar. Like you pay this much as long as you only use 5 gigs or whatever. If you go over that, you pay more, right? Same kind of idea. All right, so this is the exact same function that's shown in that graph, but think through this last example, finding each of those things using this. Your answers should match because it's the same function, but think through like how you do that using this version of writing it down, okay? So we'll pick up there. We'll just hit that real quick on Thursday, and any questions that you need to. Because Monday is test day, you should get on homework as soon as you can. The 2.4 stuff, that's all the absolute value stuff. You're good to go there. As far as I'm concerned, do stuff, bring questions if you have them. And then Thursday, we'll talk a little bit about circles. Oh, my pens. Don't steal my pens. Make a pile on that desk and this chair, please.